Let's start the dihybrid practice screencast. Now, dihybrid problems are the ones in which we are looking at two traits at the same time. Let's see our first practice problem. In pea plants, the tall allele is dominant to the short allele, and the green pod allele is dominant to the yellow pod allele. Two traits. I want to make a key for this. Okay. First, let's look at the height characteristic. There is a tall allele, and there is a short allele. Let's say big T for tall and little t for short. The next characteristic is pod color. Green is dominant over yellow. Now for both of those, I use the same letter for the same characteristic, and I use different cases to show that one is dominant over the other. Now this says show the cross between a short yellow pod plant, a short yellow pod plant. If it's short, it must have little t, little t. If it's yellow, it must have little g, little g. And a heterozygous tall, heterozygous green. So if it's heterozygous for both, it's got to be big T, little t, and big G, little g. Let's figure out the possible genotypes, the possible gametes these individuals could make. The little t could combine with the little g, and that's the only possible combination for that individual. Over on the right, the big T could go with the big G, the big T with the little g t with the big G, or the little t with the little g. Okay, I'm going to get rid of my key to make room for my Punnett square. So I want to cross this possible gamete with these four possible gametes. I'm only going to draw what I need to draw. I don't need to make a 4x4 Punnett square every single time. I want to write the genotypes of the offspring with the alleles of the same characteristic together in order from most dominant to most recessive. So big T, big G, little g. Big T, little g, little g. Little t, big G, little g. Little t, little g, little g. And there is the cross. Okay, I can see that I have a 1:1 to 1:1 genotypic ratio and a 1:1 to 1:1 phenotypic ratio. Just for practice, what would the phenotype of that offspring be? That is a tall, yellow potted plant. Okay, tall yellow. Next, what is the expected phenotypic ratio of the offspring of two plants that are heterozygous for both characteristics? That means that their genotypes are as follows. Let's figure out the possible gametes they could form. All right, four possible gametes for both. I can see I have no repeats, so I don't have to cross any out. So this will be a 4x4 Punnett square. All right, I want to set up my gametes from one individual across the top, and my gametes from the other individual down the side. This is my 4x4 Punnett square. Okay, now that I have that laid out, let's combine these gametes to see what kind of possible zygotes could result. Notice how I'm writing the genotypes, the alleles for the characteristics that are the same are written together, and they're written with the dominant allele first. Oops. Maybe you noticed that I did that. I accidentally wrote the uppercase letters when it needed to be the lowercase. Okay, now that I have that done, I want to figure out my phenotypic ratio. All right, let's identify all of the tall green plants. All right, those are all of the potential genotypes of the offspring that would result in a tall green phenotype. And I see 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. That is 9 tall green. Now let's find the tall yellow ones. There's a tall yellow. There's a tall yellow, and there's a tall yellow. There's 3 of them. Kind of writing over myself there. Next, I want to find the short green ones. There's one. There's one. There's one. And last, I want to find the short yellow ones. Not very difficult. There's just one of them. All right, that leads to a 9 to 3 to 3 to 1 phenotypic ratio. And that is actually every single time you have 2 individuals that are heterozygous for both traits and you cross them, they will always cause a 9 to 3 to 3 to 1 phenotypic ratio. Oops. There we go. 2 plants, both are tall and have green pods. Produce a short yellow pod plant in the next generation. What are the genotypes of these 3 individuals? Okay, the 2 plants, I know that if they are both tall and both green, they must have 1 each of the dominant alleles. So I don't know if they're homozygous or heterozygous for those traits. However, if they produce an offspring that is short and yellow pod, that offspring would have this genotype. The only way they could produce that offspring with that genotype is if they were both heterozygous for both traits. So I know that parent 1, parent 2, and we'll call him the F1 is heterozygous, and as shown to the left, double homozygous.